All right, Chem 11 students, this is another one of our problem-solving sessions on YouTube. The sheet that we are going to be doing today is the Stoichiometry Work Sheet II. This is on the D2L site for the class. In order to do the problems today, you will need your Calculator-O-Matic 3000. I've got the solar-powered edition. So when the zombies knock out the power grid, this guy can still do chemistry. You'll also be using your periodic table-o-matic 3000 Mendeleev edition. So let's get these off to the side. I'm not going to do all 8 questions off of the sheet. What I'll do is the first 2, I'll do number 1 and number 2, and then I'll do number 7 and number 8. All right. So let's get to it, and we'll read off the problem, and then we'll get working. So number 1 says, determine the masses of the products if 254 grams of magnesium chloride are reacted with an excess of potassium phosphate according to the reaction below. So the first thing I'm going to do is, of course, if you remember the steps from yesterday, I need a balanced chemical reaction. So let's get that down first. I've got magnesium chloride plus potassium phosphate, and that's going to yield magnesium phosphate. Ooh, do that bracket a little close. Plus potassium chloride. And the balancing in that equation, I like to put the coefficients in a different color. You don't have to while you're solving them, but put them in a different color because they help us make our mole ratios. And we know that there's a 1 here. I'm not going to show it because I think we're beyond that right now. What they gave us was 254 grams of this. And the question asked, determine the masses of the products. So we have to find the mass of both products. So basically what this is saying is, hey, we've got 254 grams of this, we've got a whole bunch of this, and when this runs out, we've used up all of that. How much of this is going to be made? All right. So if I'm relating this to these, I have to use the mole ratio, but this is not in moles, right? So I have to turn that into moles first. So I'm going to divide by the molar mass of magnesium chloride. So I take a magnesium and 2 chlorines and I add their masses together on the periodic table, and I end up with 95.21. I then divide the given mass by this molar mass, and that will leave me with moles of the magnesium chloride. Again, all the work for this substance goes here. All the work for that one will be done here. All the work for that one will be done there. And I end up, when I divide that out, 2.67 moles of this. Now that I have that in moles, I can now relate it to anything else in the equation. I can relate it to this, this, or this. Obviously, I'm going to want to relate it to these 2 things. So I'll bring it over here first. And again, I'm using my head over heels method. I find it very, very easy. And I'm going to use that mole ratio. Now my mole ratio, in this case, there'll be a 1 here and a 3 here. So that 1 and that 3 go right here. The head of the arrow is where there's a 1 in the equation. The heel of the arrow is where there's a 3 in the equation. Head over heels, 1 over 3. And that will leave me with 0.89 moles of the magnesium phosphate. Now, if it said what amount or how many moles, that would be it. But it's asking for grams. So now I have to convert this into grams. So I take that amount of moles and I multiply it by the molar mass. So I have to add 3 magnesiums, 2 phosphates, and 8, 2 times 4, 8 oxygens together. And when I do that, I get 262.87 grams per mole. And I multiply those together and I get 233.95 grams of the magnesium phosphate. So that's the answer for Mg3PO4, 2. All right, so I'll get this many grams, 233.95 grams of the magnesium phosphate. I also have to find it out for here as well. All right, so what I can do is I can bring my arrow down and bring it over like this, and 2.67 moles times my mole ratio in this case, which is going to be, the head of the arrow is where there's a 6 coefficient, over the heel of the arrow where there is a 3. Head over heels. So 2.67 times 6 over 3 is 5.34 moles of potassium chloride. It wants the mass, so I now have to multiply by the molar mass, which is 1K and 1Cl added together from the periodic table, and that will be 74.55 grams per mole. And when I multiply those together, I get 398.1 grams of KCl. And those are the masses of the two products. All right. So take a look at your work. Make sure that you have worked things out the same way. If there is a problem or a difference, contact me, right? Get in the know. Ask a question. Sir, I got this, you got that. Where did I go wrong? Or maybe I went wrong. Who knows? Rarely happens, but it could. So that's the answer for number 1. Pause the video now if you got to get that down, or if you want to look at it and see, check with your work. Pause the video. I'm going to set up question number 2. All right. Question number 2. Has the synthesis of ammonia involved with it. And if I balance that out, there'll be a 3 here and a 2 there. Again, the number one thing that I need before I can do any stoichiometry, which is the study of recipes in chemistry, is the recipe. This is how I make that product. And it says I have 175 grams of this, which means I must have an excess of this, a whole bunch of that left over. And it wants to know what mass of ammonia can be made if I have 175 grams of nitrogen gas and a whole bunch of hydrogen, which means my nitrogen will run out first. I'll have tons of this, so this will kind of limit how much of that I can actually make. So I want to relate this to this, but I can't do that first. I can't use the mole ratio because this is not moles, it's mass. So I got to change this to moles. So I'm going to divide by the molar mass for nitrogen gas. And the molar mass is simply 2 nitrogens off the periodic table, so 14.01 plus 14.01, and that's 28.02 grams per mole. I'm going to divide those two, and when I do, I get 6.25 moles of nitrogen gas. All right? Now I can relate this to any other thing. Now I have moles. I can use the mole ratio and go one way or the other here. I'm going to be going this way. So 6.25 moles times my mole ratio. Now my mole ratio is head over heels with this arrow. So it's 2 over 1. There's a 1 here that we don't see. So 2 over 1. And that's going to be 12.5 moles of ammonia. The question wants mass, not amount or not moles. It wants mass. So now I have to multiply that by the molar mass of ammonia. So the grams per mole of NH3. Now again, I want to remind you, a common mistake. When somebody's getting this molar mass, they'll use 2 N's and 6, 2 times 3, 6 H's. Don't do that. This 2 is already accounted for right here. For your molar mass, it's just the N and the 3 H's. So just this. Don't include this. It's already accounted for, okay? So 1 N, 3 H's, and that's 17.04 grams per mole. I multiply that out, and I get 213 grams of ammonia. And that is my final $1 million answer. All right. Okay. This is bothering me a little bit. I'm going to see if I fix that. There we go. All right, so that's the answer for number 2. And let's do number 7 and 8. Number 7 and 8 have a little bit more to them, so they're a little bit bigger problems. Bigger, but the same stuff. So if you got to get number 2 down, pause the video now. I'm going to set up number 7. All right. Number 7. Number 7 is dynamite. All right, that's the one where today you found out what the formula for dynamite was. And CO2 plus H2O plus N2. So there's my skeleton equation. I will put to balance this one off. It is actually kind of a weird looking balancing. There's a lot of big numbers here. All right, so there's our balanced chemical equation. As odd as it looks, that's it. So it says I have 3.45 kilograms of dynamite. And it wants to know how many grams of carbon dioxide will be released into the air when it explodes. All right, that's part A. So I'll put a little A here. A is asking for the mass of carbon dioxide. B wants to know how many molecules of nitrogen gas are released into the air, because it's a gas, it's in our air, during the same explosion. So we'll do A first, and then we'll do this. All right, this was 2 parts, this question. All right, so first thing I have to do, kilograms, not going to cut it. I've got to change it to grams. So you guys did this stuff like in grade 8 or even maybe grade 6, whatever it was, changing kilograms to grams and meters to millimeters and all that. That's elementary school stuff, so I'm sure you're pretty good with that. There's 1,000 grams in every kilogram. And so that ends up being my new mass, 3,450 grams of the dynamite. Then I'm going to bring it over, but I can't because it's still in mass. I got to change that into moles. So I'm going to divide by the molar mass for the dynamite. So again, I don't use the 4. It's just 7 of these, 5 of these, 3 of those, 6 of those. When I add those up, I get 227.15 grams per mole. I take grams and divide it by grams, they'll cancel, and I end up with 15.19 moles. And then I'm going to bring that up here. 15.19 moles, and I'm going to multiply it by my mole ratio. My mole ratio, this looks like a weird one here, but the head of the arrow is where there's a 28, and the heel of it is where there's a 4. Head over heels, 28 over 4. 7, right? 28 divided by 4, 7. 4 becomes 28. It increases by 7, so this will increase by 7. So I do that. And I end up with 106.33 moles. All right. The next thing I'm going to do is I'm going to multiply by the molar mass because it wanted mass, not moles. So CO2, I take one C and two O's. I don't take 28 C's. That 28 is accounted for here. Just C and two O's. And that ends up being 44.01 grams per mole. I multiply that and I end up with 4,679.58 grams. When I multiply moles on top, moles on bottom cancel. That seems like a lot, but that's less than 5 kilograms. It's less than 10 pounds, right? Or it might be right around 10 pounds. So it's not a ton of carbon dioxide. So like tons of the stuff. The number looks big, but again, a gram isn't very, very heavy. All right, our next part, I'm gonna take this, I'll do it in blue, green over here. I'm gonna take this and of course bring it over. Draw the head of the arrow a little bit bigger because we are using head over heels. And my 15.19 moles comes over. And I'm gonna multiply it by the mole ratio. This time it's gonna be 6 over 4. The head of the arrow is at 6. I know it looks like it's under the 10, but we're doing this for nitrogen. So 6 over 4. And that means my moles are going to become 22.785 moles of nitrogen gas. All right. So this one didn't want mass. If it wanted mass, I'd multiply by the molar mass and get the grams. This one wants molecules. We haven't done that yet, but you have in a way. We, earlier on in this unit, took moles and turned it into particles. Remember the two loops? One was particles to moles and then moles to mass. Well, this one we have moles. We're just going back to particles. So I'm going to move this down here a little bit. We're going to finish this one down here. And I'm going to take 22.785 moles and I'm going to multiply it by what a mole is. And a mole is 602 hexillion, or 6.02 times 10 to the 23 molecules per mole. And when I do that, moles on top and moles on bottom will cancel when I multiply, and I'll end up with, using scientific notation, 1.37 times 10 to the 25 or 25th molecules of nitrogen gas. And that is my answer for B. All right. So I still use the mole ratio to find my moles of this. So I brought the 15 over, multiplied by the mole ratio, got my moles of nitrogen gas, right? And then I use those moles of nitrogen gas and convert it into molecules of nitrogen gas using stuff that we've done before. All right? Anyway, that is number 7 done. Pause the video right now if you want to take a look at it. I'm going to set up number 8 and get that one finished for you. All right. Number 8. Ooh, that's a bad looking 8. Number 8 is a single displacement reaction. They want you to show the single displacement between magnesium and phosphoric acid. Names and formulas, you gotta know them. Right now we should not be struggling and spending 3 or 4 minutes trying to do names and formulas. That should be automatic by now, or I hope it's getting to the point where it's automatic. Maybe requires a little bit of thought. Magnesium comes in, it wants to kick out the hydrogen. Remember, this is on our activity series for single displacement reactions. So magnesium kicks out the hydrogen, it forms hydrogen gas. And the magnesium now goes out with the phosphorus, and I use my crisscross rules to get that. Now I have to balance this thing, and to balance it, 3, 2, and 3 will go in those positions, and a 1 here, but I don't show it. So there's part A done. A was doing the equation. Part B, it says for the magnesium, I have 4.2 times 10 to the 24 atoms of magnesium, and wants to know how many grams of hydrogen gas will be produced. All right. So with this one, I'm not starting with mass. I'm starting with atoms. And I can't go atoms over to here because I'm using the mole ratio, and this isn't moles. It's particles, right? It's atoms. So I have to turn my particles into moles, and we've done that before, right? So what we're going to do is take that, and we're going to divide it by 6.02 times 10 to the 23 atoms per mole. When I do that, atoms divided by atoms will cancel. I'm losing coordination here, people. Atoms divided by atoms will cancel. I will be left with moles, and it's going to be 6.98 moles of the magnesium. Now that I have it in moles, now I can use my mole ratio. So I take my 6.98 moles over and I multiply it by the mole ratio, and my mole ratio, the head of the arrow is where there's a 3, the heel of it is also a 3. That's nice and easy for me. That means that this ends up staying exactly the same. 3 over 3 is the same as 1. Any number multiplied by 1 is the same. And now I'm going to multiply by the molar mass of hydrogen gas because it wants the moles here. The molar mass of hydrogen is just 2 H's on the periodic table, so 1.01 plus 1.01, which is 2.02. This 3, again, already looked after right here. All right, don't need to, it's not 6 hydrogens, it's only 2. When I multiply that, I end up with 14.1 grams of hydrogen gas. All right? And that is my final answer for B. So B had that final answer. All right. Now C wanted to know the mass of this. So I'll put that in here. C wanted to know this mass. So C wanted to know how many grams of the magnesium phosphate am I going to get. Now I'm running out of space here, so pause the video because I'm going to need this space. I got to erase some of this. Pause the video if you got to get A and B done, and I'm going to erase and do the next part. All right, now to do C, C is saying, look, if we took this many atoms of magnesium, how many grams of magnesium phosphate would we need? Well, I kept the earlier work where I got the moles, because if I have moles, I can mole ratio to any other substance. And I'm going to have to go from this one to this one. All right? So I kept that moles there. Right? And all I'm going to do now is bring this over to here. It's going to be 6.98 moles times my mole ratio. My mole ratio in this case is going to be a 1. The head of the arrow is where there's a 1. I can't see it, but I'll draw it in, a 1 there. And the heel of the arrow is there, head over heels, 1 over 3. And that's going to make that into 2.33 moles of the magnesium phosphate. Remember, everything in this column refers to this. Everything in here refers to that, right? Keep our information organized. The next thing I'm going to do, because it wants mass is multiplied by the molar mass of the substance. So I'm going to take 3 magnesiums, 2 phosphates, and 8 oxygens, 2 times 4. I'm going to add all of that together, and I get 262.87 grams per mole. When I multiply those two, I get 612.49 grams of the magnesium phosphate. And that is my $1 million final answer for C, 8C. Anyway, number 3, 4, 5, and 6 are still out there and unknown. Give those a try, as well as work these out on your own first. I always say try to do it on your own first. It's better to do it that way. Hopefully you're getting the same answers I am. I will post the answer key for the entire sheet on the D2L site later today. And, or sorry, not the D2L, your EDSB page for the class. And give it a look. And hopefully we get a lot of the same answers. If you didn't and you're not sure why, reach out to me and ask for help. All right? You can't just sit there and not know. All right? Anyway, I hope everything is crystal clear, and great minds think alike, hopefully, on this one. I'll talk to you soon. Bye-bye.